Okay, I'm going to explain our basic ideas.
Okay.
First, the elevator talk
Sure.
level. We believe that
Talk loudly.
talk loudly.
Speak loudly.
We believe
Yeah.
that absolutely all projects,
Who's we?
Kai and I
Okay.
and friends of ours,
Okay.
that absolutely all projects need to be framed by an initial top 10 critical objectives or requirements, all of which are expressed numerically for clarity, and all of which represent either performance or cost or quality improvements compared to today's status for the older or reference system.
And the question I had before is expressing them numerically as in ordering, like the 1, 2, 3, or expressed numerically in
No.
how long it will take to get from here to there, or expressed numerically on the quality of the end result?
Right. So it is the level of the end result, whatever
Okay.
it is. How secure, how user-friendly, how fast, how cheap. It's
Actually, is it recording now?
uh,
Yeah, because there was a noise.
it was
It's the
annoying.
mail.
Just
It was a mail. Okay, we got a mail.
You
We
got
got to already have a question from our readers. Okay.
Yeah.
So I like the fact you want to measure the end result already before it arrives.
Well, first we want to be clear about the end result so nobody can misunderstand. And we use numbers to be clear.
Okay.
When the project is running, we use numbers to track progress towards those numbers. And when we reach the numbers, project is done by definition. We've reached our aim. So we get feedback and measurement during a project in cycles to denote progress towards the numeric goals.
So give me an example of such
By
a
the way,
requirement.
okay, so here's something which I think is kind of silly to imagine that it'll get on that. Okay, this is from our Java Zone talk today.
That's horrible.
It's a set. I think we give that up. It's like
Oh, there you go.
well,
It's all upside down.
That's a set of requirements. Yeah.
Okay.
Okay. I can tell you this happens to be from Symbian in London with 800 developers and 200 in Sweden. And they were an 8-year-old organization, and they needed to reorganize to get greater productivity and be more competitive. Okay, so I talked to the guy in charge of planning for the CEO, Mr. Barretts, and taught him the basic idea that all of the things that were important should be quantified. So here you see about 12 things. There is a scale of.
So just for who's watching, there's a column right here. It looks like an Excel file. Column of business objectives going.
These
like
are the
12
names
objectives.
or tags of the objectives.
Yeah, and then
They are
there's a column.
defined.
Yeah.
They're defined in the next column by a scale, a measuring scale
Okay.
of some kind. You know,
So,
miles per hour.
For example, time to market, and then the measure is normal project time from GT to GT5.
which are 2 stages in the development process.
Okay. And then the goal times 200.
The goal is that was 2005, but
Uh-huh.
I didn't want to give away the exact dates
Okay.
we were aiming for, so it's 2000 and something.
Okay.
Yeah.
And the goal is to have it
Less than 9
less
months.
than 9 months. Okay.
And the stretch goals have it more than
Less than
6
6
months.
months.
Less than
Okay.
6 months. Yes.
Then you have volume, value, profit, cash.
These goals, if we attain them, impact stuff at a higher level. And we're really talking to the chief financial officer and the chief executive officer. What we're saying is if we attain these numeric goals, it will have an impact. It just means it will have some impact. We're not saying how much, on volume of sales, not on value of sales, but on profit and on cash flow. Okay, so this is just indicating that these things at these level, they're intended to have an impact higher up on the business.
Okay, so when you just start a project, on the very first day,
Yep.
you come up with 10 or 12.
I maximized to 10 just arbitrarily. I said that most people cannot handle 10. And there's no point in going to 11 if you can't handle 10. So when we've done 10, we'll look at 11. It's a prioritization scheme.
Okay.
Top 10.
So on the first day of a project, you come up with a maximum of 10 things that you want to measure at the end product, that you want to have as a goal for your development.
Well, let me rephrase that. You're right in what you said, but I'd rather rephrase it. We come up with 10 things that the powers that be, i.e. the directors or whoever, have told us these things count. These are what we're expecting for our money. So it's the top 10 in their mind for a critical set of stakeholders. In this case, the guys putting money on the table for the project. If you ask them, what do you want? They say, we want more productivity. I said, we write down productivity. And we define it later numerically. What else do you want? If you got productivity, well, we want more consistency between the different business units. Okay, we write down consistency. And we define it numerically to make it clear. So the numeric definition is just a tactic for making things so clear that people cannot misunderstand them.
And how is this different from regular requirements management?
Well, regular requirements management doesn't normally quantify qualities at all. You would find whole books that don't even mention the subject about requirements.
But for example, a lot of times you would have requirements about performance. Isn't that something like that?
It's very much like that. So, and everybody can and does quantify performance as a goal. No problem.
Okay.
Now, the moment you get to the ilities, you get a problem. If I said to you, quantify robustness, you're stuck.
Quantify robustness.
Yeah, quantify. So it means I want a very robust system.
Okay, here's an example. When I teach people to do unit testing,
Yep.
I want their tests to end up as robust tests. So I will quantify robustness as that this test should last for at least 5 years without you needing to change the
Great,
test.
you have quantified your robustness idea and made it clear to me by giving that number.
Okay, that's
But
good.
most people, when you say robustness, they're just sort of like, well, I sort of know what it means and I know I want it, but I haven't got it. I've never quantified it in my life. I never learned to do it. I never saw anybody doing it, and I don't off the cuff know. But sometimes you say, look, relax. Just think about it for a while. Let's play some games here. I have ways of easing people into it where most people can, in fact, define it quantitatively if I coach them into it same day.
Okay.
But now take another one, user-friendliness. That's the most popular one of all. How do you quantify user-friendliness? Yeah.
Well, if we think about it this way, then user-friendliness will be the amount of what the fucks per day.
That's one way of doing it. It's one dimension.
Well, less than 2, like or less than
right,
1
okay.
per month.
So you have the principle.
Yeah.
Now, for example, in my book, Competitive Engineering, Scales of Measure, Chapter 5,
Okay.
you will find 13 different measures of usability which you can use simultaneously, such as intuitiveness, intelligibility, learning time, error rate, and productivity, and things like that. So one thing we've learned about a lot of high-level qualities is that they are what we call complex, meaning they can be decomposed into a set of sub-qualities.
Okay, I'm just going to turn this off because it's making light in the picture.
Right, good enough. Yeah.
Okay.
And so one of the things people have to learn is that sometimes you can't seem to quantify something because in fact it is many things. And you have to use what we call Cartesian analysis, Rene Descartes philosopher, to decompose usability, maintainability are of this nature. Maintainability in Chapter 5, you'll find it decomposed into 14 different things like problem recognition time, administrative delay time, problem analysis, and
But
some
who
testing.
came up with these 14 things?
A guy called Ireson wrote a book called Reliability Handbook in 1966, and he published the pattern there, and I stole it and put it in my book and credited it.
Cool. So some guy said, okay, this is what maintainability is.
Yeah.
But aren't you afraid that you start with this and you start slicing these into what something means, and you measure each thing? Does it ever get out of hand? Where you have so many things to now look out for, and you end up with this whole big book of demands that no one can ever finish in time to actually finish the project.
You're putting a lot of assumptions in there, right? So
Well, you just
no, it's okay.
you
I
had
need
3
to go slowly.
ilities, and each one of them 14 sub-ilities.
Yes, yeah. So
and
you may have 50
out
to 100 simultaneous things. So we have
Yes.
small clients like Confirmit in Oslo who deal with 25 simultaneous things. And we have a case study about that, which I can show you. And what they do is they take, for example, their deliveries cycles, and they first they take the 25 and divide them amongst their team of 13 developers and give 4 or 5 of those aspects to 3 to 4 developers
at the same time.
at the same
Like
time.
each one gets one, or
Well,
these
the
4 are in
25
charge
are
of these 5?
divided amongst the 13 into 4 teams. I've got
So
a
you have
picture of that.
4 teams, and each team is in charge of 4 or 5
That's right. That's right.
ideas.
So first there's, and none of that. They have 12 weeks to deal with those 4, and typically on
Why 12?
because they decided years ago they always wanted to release to the world every quarter of a year. And they decided to keep doing that. So they said, okay, our big release cycle of the world is a quarter of a year, 12 weeks. But we've also decided now that we will release value every week to at least a trial customer and measure what's going on. So, so typically 1 week they will pick one of those 4 that they have and say, this one we haven't done anything on it, shall we work on it this week? Now if they get lucky, that week they get to their goal and they're done. But let's say they only get halfway. That means another week they have to deal with getting the other half of the way. And I can show you a picture.
And then what happens?
Okay. I can pull up pictures and really bring it. What happens?
No one will see the picture, so you have to explain.
That's right. Okay, but if I'm explaining to you and we weren't playing to the camera, I'd do it differently, but all right. Okay, I can do it already. Okay, now what happens is when they, let's say they have 4 things. If all 4 things are at 100% of the goal, they've reached it.
Yes.
Even after 9 weeks, they're done.
True.
They can go home and take vacation for the next 3 weeks. And so all the teams, in fact, it turns out that when we look at the data, and I have examples of it, after 9 weeks, almost everything is at either over 100% or about 96%. So the last 3 weeks are just used for prioritizing the weakest ones that aren't quite at 100 and tuning them and pushing them in. But largely they typically take 5 to 10 things and accomplish all of them within 9 of the 12 weeks.
Are there always things that are Is it possible that one of those things will take much longer than you thought?
Yes.
And then what happens?
But it also happens that some will take much less time than you thought. So they give an example in the confirmance study where they thought that we need to save 40 minutes for doing something, for putting out a markets survey.
Yeah.
Research.
So that's their methodology of how to handle requirements and how to develop.
It's
not part of your ideas.
They estimate at one point in a week how much do we think we'll accomplish. And they may say we'll accomplish the saving of 20 minutes of the 40 we need.
Yeah.
But in the real case, they actually saved 38 minutes. And one guy spent the weekend bringing him over to the 40, and they were all done in 1 week. So they got lucky. So you get lucky sometimes. It varies. But the point is they're constantly tracking in real time their measurable accomplishment. And wherever they are weak, or i.e. not reaching the goal, that's where they put in their effort. I call that dynamic reprioritization in weekly cycles.
Dynamic reprioritization.
Yeah, dynamic means you're making your decision that same week. What are we going to do this week and
just
why?
in time.
Just in time. After you have the feedback from all... Yeah.
So if I'm trying to understand this whole thing, what do you call this? Value...
Well, we have...
driven?
Okay, our method is called EVO, which is short for Evolutionary Value Delivery.
Evolutionary
And it's
value
not necessarily an acronym like Earned Value Optimization. We've played with things like... It really is a concatenation. It's evolutionary shortened to EVO. That's what we've called it for decades. So that's known as. That's what it's...
And it doesn't talk about the methodology of delivering that. It just talks about the quantification ideas, right?
No, it talks about everything, including the methodology of delivery.
So it talks about from requirements to delivery, everything.
Absolutely.
So is it a replacement for other methodologies, or is it an additive methodology?
Some of our clients who, for example, already have, let's say, Scrum in place.
Yes.
One example I can tell you is Deutsche Bank in London. It's not a secret. They have published our EVO standard as an envelope on which all agile methods should be subject to have them managed towards the numbers. Mm-hmm. Okay, because they acknowledge that the Scrum and XP, they aren't very good at this multi-dimensional quality management. They don't even try. So what we do is we do the multi-dimensional quality management with EVO, mm-hmm. and then we have within our own method the equivalent of a Scrum, Sprint, and Cycle. But we say, no, you're already doing that. It's good enough. It's essentially the same thing. So you keep to your Scrum, but you need to add to your organizational thinking at, let's call it product owner, project manager level and above, some better organization of how you do things, more clarity in what is the project all about.
So having more specific goals. It's all about having specific goals.
At the right level. We work at 3 levels, simplified. The organizational level, like how much money do you want to earn. The stakeholder level, like how good a contact should the firemen have in a smoke-filled building from the emergency thing. And then the IT level, how user-friendly does the IT system have to be for a fireman who's going to use it without a lot of training. Uh-huh. And then you have to design, how do you design the interface or whatever so the fireman can learn to do it quickly, so that they can save the people in the building and reduce the terrorist threat and make Norwegians feel safe.
So what if these three levels may contradict each other? For example,
They
car
don't.
maker.
They are totally complementary.
Car maker wants to have a safe car so it will sell,
Yeah.
but if they make the parts too expensive, they actually lose money.
Okay, so here, all requirements of this nature are
Yeah.
inherently always in some sort of conflict with all others, if nothing else for the common purse, the budget.
Yes.
They will all cost money. So there was some degree of conflict is completely normal, necessary, and unavoidable. So we don't view conflict as something to be avoided. What we do is we prioritize so that when in conflict, the highest value things get done. That's how we, in simple terms, that's the main resolution of conflict, is do the high value stuff early and
But
first.
do you consider high value based on which level?
Right. Well, we consider all three levels simultaneously. There's a model for the organization. There's Kai should explain this to you from the point of view of a project called Bring here in Oslo. There's a case study.
Kai
of-
is not here.
Well,
Is
Kai is not here, but he's coming back. But he has mastered the multi-level use of this better than anybody, and he really invented that. So, but they have this organizational level, which is what the big organization want. Then they have what we call stakeholder level, and you can have 40 different stakeholders. What are the stakeholders? These are like the individual firemen going into a smoke-filled
Yes.
building. Okay, and then you have the IT system, which is maybe your handheld emergency system communicator, okay, which has some software in it. And then the question is, how reliable does that have to be in a smoke-filled building? Right now, they can't do it. As they're complaining in public on television that the firemen say your emergency system you spent a fortune on will not go into a smoke-filled building with us. So somebody forgot that stakeholder, the firemen going into a smoke-filled building in an emergency system. It's a public scandal in Norway. Everybody knows about it.
Wow.
Yes. This is like last month.
Well,
Okay, I mean, political scandal.
I'm new to Norway, so I only
Yeah.
see the good things.
No,
Yeah,
okay.
I'm still in the good
Okay.
things phase.
But this is I use the example of the emergency system because it has become a national scandal. They spent a lot of money on it, and it wasn't ready, and 77 people died. And
Wow.
there's an official commission that has basically said the fucking system didn't work. Neither the people, the organization, the leadership, or the emergency system. And you spent all this money and all this time, and you let 77 people die.
And who built this?
It's a project. Well, Siemens and Motorola built the core hardware software for it. They had the project, and they did not deliver a system that people like firemen going into buildings can use. They say publicly that although my fireman chief would like to shut me up and fire me, I'm going to tell you anonymously that it's crap and it doesn't work and we can't use it. And so this goes right up to the prime minister level, television every day, and ministers having to answer, why the hell doesn't this work? Firemen can't save people from dying in a fire caused by a terrorist. And we had one in the prime minister's office, 22nd July last week. The bomb hit the prime minister's office and killed some of his employees, and he happened to be in another place.
Wow.
So it gets very near, very, very personal.
Huh.
So it's a great example of systems we haven't been able to build.
We're not connected to the TV yet, so I didn't even know that.
Ah, well. But
See,
you
in Norway, you're happily out of context.
Yes. No, but every Norwegian knows a lot about this now. They've all spent the whole summer
Wow. Well,
studying it, big missions and trials, and God knows what's. Everybody
So,
knows it now. It's a good example of systems that fail. By the way, the system failed not only at the hardware-software level, clear failures there.
it was more
But
like an integration problem,
Well,
isn't it?
no, but it failed at other levels. For example, when the terrorist bombed the building, somebody spotted his car and got his license plate and rang the police and gave the license number. The policeman wrote it on a yellow sticky, put it on the wall, and for the next 15 minutes, which is enough to kill about 20 young kids on an island, it didn't get into anybody's system reviewing the emergency, and they didn't catch him, and he got down and he murdered about another 70 people. As a result, police cars were riding right next to him, and they didn't know his license number because somebody put it on a yellow sticky. Now that's not, it's sort of an IT problem, but not quite.
That's the guy who worked with the
terrorist.
The terrorist.
Breivik.
Okay, yeah.
Yeah.
Okay.
So in other words, is this an IT system thing? You say, well, no, it wasn't in the IT system, therefore it's not their fault. Okay, but it's a human system. Some guy has got the license plate of a terrorist, and he puts it on a yellow sticky on the wall in the middle of the whole terrorist action and doesn't do anything for a while. And people having high-level emergency meetings, 2 of them, and they didn't know about the fact that we knew who the terrorist was. And they didn't do a thing. So he got to the island and killed 70 kids.
Yeah.
That really, that's a simple example of, there's a thing called the Evolutionary Commission, who published a report now, and they they got access to everything and picked everything apart, and they told it like it is about how bad the systems are, both the political responsibility, the departmental responsibility, the IT systems. Nothing's working.
And all this could be avoided if they had just used value.
Well, if they'd really used our methods, things that might have been better. But they didn't even have good leadership. They didn't have good secretaries of state, kind of thing. You know,
Okay.
they had people who knew that a terrorist threat would be at the government building for 7 years, and they should close it off so you couldn't park cars with bombs there. And they never bothered to do it. This is a major scandal everybody knows about. This morning on television, the minister was sort of having to answer to these kinds of things.
Okay, so I'm feeling like we're digressing just a little bit.
I'll tell you why it seems like a digression, because we're now talking about systems engineering.
Well, we're talking about people.
Exactly, and systems engineering brings in people, not just the code.
True.
Yeah. So one message we try to get to people is the values you state are independent of any artifact in the system, hardware, software, people that does it.
Okay.
So in order to achieve the values, you have to be ready to use anything: people, organization, motivation, contracting, and hardware and software in any combination that best suits your
Most
need.
software organizations are not equipped to deal with this kind
Exactly.
of requirement.
Exactly.
That actually requires you to change the way people work.
It requires you to think of the thing as a total system rather than just a hardware software project.
And then you have to be part psychologist as well, just to change
Well,
the way people
let's say you
behave
have
with
to
your
have
system.
good people on your team somewhere.
Good people.
Yeah. In other words, psychiatrists. And we have another national scandal.
Should
We've
all
totally
software
lost.
teams
wait
have a
minute.
psychiatrist? What do you think? Or a psychologist?
Probably.
Probably.
But the problem is, in Norway, the psychiatrists who were trying to rate the terrorists have differed so much that they've totally lost all credibility in Norway. So nobody believes in the evaluation of any psychiatrist about whether people are culpable or not. It's a major scandal right now.
So if all psychiatrists are out of jobs, now they'll come to the software industry.
Now you're getting really off track.
No, I'm just thinking. I'm just systems thinking. Actually.
Yeah, okay. No, but what I've discovered is there is no clear concept of systems thinking, but there's a lot of programming thinking and hardware software project thinking. But the moment you say, where does the system fall apart, it's because, for example, they didn't do simple things like, what do you do with the yellow sticky? It's like, that's not a computer, that's not hardware, that's not our business, so we don't handle that.
That's why a lot of people still prefer to just draw things on a whiteboard rather than use software to manage requirements or manage the tasks for this week. It's just much easier and nicer, and it appeals more to people, I would guess. I'm just thinking about...
I don't practice or believe in doing requirements on whiteboards. I believe in writing them in text with defined scales of measure and defined numbers immediately. So when I work with people, that's my working mode. There is no whiteboard.
But you work on a paper or on an Excel?
I work on a Mac.
Yeah.
And they say something, and I type it in so everybody in the room can see it, and do it with text.
Okay.
And we have developed a language called planning language, short language.
Language, exactly.
Language. In Norwegian, planspråk.
Planspråk.
Yeah.
Planspråk.
Yeah, and this planspråk is how we express our ideas about requirements and designs and that sort. And the competitive engineering book is a textbook or handbook on the planning language. And plenty of examples right here, right now. If you want to take a look at language.
Well, they won't be able to.
No, they won't be able to say it. So
but if there's a thing you can draw, that would be interesting.
You can't draw that stuff. However, language does have a set of well-defined drawn and typed icons which are purely symbolic and graphical.
So where would people go to watch these drawings?
Okay, here.
Just say
I'll
it.
can I
put it
write on this? Okay.
Yeah.
I'll do drawing. Here you have your system. Let's call it emergency. Okay.
Emergency system.
Function. Okay. And here, emergency. This symbol here is what we call the function of the system. What it does? Well, it ties together firemen, police, and all, and army, and God knows what.
Yeah.
In some way, it helps them communicate what's going on. Now, here I'm going to draw a big arrow here.
Let's see if we can do this.
And let's call it
Yep.
Let's call that arrow communications ability. I'll just call it comms.
Okay.
Okay. Now let's just now. By the way, the tip of the arrow represents some perfection in communications. Every message gets to everybody instantly, perfectly. Okay.
Well, wait, I kind of lost you. What are
Okay.
you trying to draw here right now?
This arrow is a scale of measure of varying degrees of good or bad, something or other.
Yeah,
in this case,
what is the point of this drawing? What are you trying to explain to me right now?
I'm trying to explain about multidimensional critical quantified attributes graphically.
Okay.
So how we
Sounds
do it
scary,
graphically.
but I'm interested.
Hey, okay, yeah. Well, there's a graphic language here. So basically, in the graphical language, all these critical characteristics, we represent them as arrows. So let's just say there are 4 different things: robust, does it fall down or not?
Yep.
Secure, and fast, and communications ability. Let's just take any one of them. There are always 2 points, and I'll write past and goal here. Okay. There are always 2 points on that arrow. The past is how bad the old systems are, whether they be manual systems or old electronic systems, doesn't matter. But the old police system, the old police to fire system, there are such systems. That's the level of communications effectiveness there. Okay, let's call that the 0 point, the baseline, the benchmark. Now, we want to. This system isn't good enough because it doesn't work all over Norway. It doesn't work in smoke-filled buildings. Da 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 da. And our goal is that absolutely every emergency person, police, fire, in absolutely every critical situation, can communicate anything vital to them. Let's call that the goal, and everybody can agree that's a nice-sounding goal.
Yep.
Okay.
So it's quantifiable.
It's quantifiable.
What's the number?
Well, let's just say 0% represents how bad you were before, and 100% represents achieving all those things you want. Okay.
So why aren't you putting a real number here? Why aren't you just talking about
because you
percents?
asked me to do it graphically, and I can do real numbers. I just didn't get there yet.
Okay.
So to get there, we have to define this scale of measure. Okay. So we write scale. Actually, in graphics, we have a graphic called scale of measure that looks like that.
Okay, a scale of measure.
Scale of measure. Okay. Now I'm going to define a scale of measure. Now I can't do that graphically. I've got to use words, but I will invent a scale of measure, percentage of all emergency services that can communicate in real time 100% of what they want and need to do. I now have a scale of measure where 0 means nobody can communicate anything to anybody ever that they want to, and 100% means all services, all the firemen can talk to the policemen, can talk to the army about anything they want in real time at any time, no matter what. That would be 100%.
Okay.
Okay. Now let's say in the real world we realize that we're not going to achieve. We've already had years of building the system to understand that it's not done in a year or 2 or 3. We can't maybe get to 100%, but let's just say for the sake of argument, by the year 2013, we wanted to get to 80%.
Okay.
I would model that as a goal to reach 80% of this goal by 2013. Maybe the 100% goal is 2020 or 30, or they talk numbers like that. Yeah. And the past is, let's call it 2012. That's just our reference level. You know, it's not like they're doing nothing necessarily, but it's our baseline.
And when we're discussing multi-level, we also have to connect all these things together, right?
Right.
I mean, sometimes it can work perfectly here,
Right.
and here,
Right.
but there's a connection between these two. If one of them is unit, isn't that true?
Well, there are relationships which we can call, for example, if you drive your security up to extreme levels, you will destroy your user friendliness.
Yes.
You'll destroy it for the hacker and the user. You'll have a 25 abstract digit password.
Yeah, but where does, for example, a sticky note fit in here? To take account of.
Okay.
Say, where do people put sticky notes?
Sticky note is a technology. Oh, okay. So there's something I haven't modeled here, and I'll model it right away. Somebody says sticky note is the solution. Okay. Agile people believe that sticky notes are the solution to everything. Okay. So we say, fine. You're an intelligent man, and you said sticky note solution. Now tell me how far we move along this. Here, I will have a thing. I'll just call it SN for sticky note. And I'll draw it as a rectangle. And you tell me, will we get to 80% of all necessary communication by 2013 if we use sticky notes? And they say, no, you won't. Okay, well, what how far will we move from this reference point? We are a little bit. I say how much? Just to say, they say sticky. Here, I'll do it graphically. See, sticky note. Okay, is a rectangle here, and let's just say for the fun of it, somebody says we will get to 30% of our objective using sticky notes. So that is the impact or power of the sticky note design for reaching our goal.
Interesting.
Yeah, this we call impact estimation, and
Nice.
it's a method I have invented and developed and have the patent on and copyright.
Ooh, so now I can't publish anything about it.
Oh yes, you are strongly encouraged
It's
to publish.
patented.
You have my permission.
Okay.
It's open source.
And it's now recorded.
It's just that nobody else can steal it and claim victory, because that's
okay.
all. But everybody's welcome to use it, so it's absolutely open source.
Mm-hmm.
Absolutely.
Okay.
It's I don't want anybody claiming they invented it when they didn't. And we've
Mm.
got doctor's thesis research going at Middlesex University to thoroughly research all that stuff and that. Yeah.
Noted.
All other methods. No. Okay. So here's the graphic. The graphic is sticky notes or whatever is good for 30% according to somebody's claim or estimate, which can be
Sure.
right or wrong.
Yep.
Maybe the reality is only 3%, right?
Maybe.
But what we do with these claims, we say, what is your evidence? And they say, well, this sticky note system got to 30%. So that's pretty good. Or has any sticky note system in the world ever got to that 30%? Not that I know of. Oh, well, then why? How did you get your 30%? That was pretty cheeky. Okay. So we have a process of estimation where we can see how good the estimate is. But if the estimate is solid, has what we call high numeric credibility, 0.0 is no credibility, 1.0 is perfect credibility based on the evidence and the source of the evidence, we will say, that looks good. Have we got anything better? No. Okay, let's do sticky notes on the first iteration and see if we get to 30%. It's just a way of making a decision, maybe a wrong decision, but it's the only decision you can make is you don't know anything about the other 10 alternatives. And let's just say you did this and you got to 3%. And you say, well, somebody has an inflated notion of what sticky notes are good for, but that's all they're good for, and they're nowhere near solving our problem. So now, forget the damn sticky note stuff. Let's talk about something that really will have an impact. What is it?
What if I took this value system and I said, instead of building a product, I'll use this value system to build a team. The team is the product. So I want a team with quantifiable attributes. For example, a team that can communicate with the customer. How do I quantify that? Because what I'm looking for here is, can this apply not just to a product, but also to organizational structures as products?
Let me just take that one question. People communicating with customers.
Yes.
Okay. Now, I'm going to intentionally take a very narrow slice, but a very realistic one, which I know a lot about. Okay. So we have, in 93, I published a book called Software Inspection, 500 pages. Okay, so we're going to talk about software inspection as a way of measuring communication. Okay. In the competitive engineering book, there's a chapter on specification quality control, which is essentially a 30-page summary of the 500-page book. Okay, now, so we do that. Let's just say, for the sake of argument, that your customer has written something down, or you've written something down, and you'd like to see how good is the communication. Okay, now, we have a little exercise we do, got plenty of real examples of it, plenty written on it. We agree to the following standard, that this communication should be unambiguous to the intended readership. You see the point?
Yes.
And it should also be clear enough to test. We're talking requirements here. And I just ask people, do you believe in that standard? Clear enough to test and unambiguous to the intended readership. And they say yes. It looks stupid if they said no. It should be ambiguous and unclear.
I don't think you can measure ambiguousness.
But you have to listen to me before you make that decision, because I will tell you how to do it. Okay. We do it all the time, and nobody asks that question.
I'm just trying to sound smart. Okay,
no. Okay. No, that's fair enough.
No, thanks.
Okay. Now, let's take a simple example. Let's just say the phrase is highly robust software. I'll write it down. Let's just have a phrase.
When the team communicates with the customer, they write that.
Highly robust software.
Sure.
And by the way, that's a real statement in a real system by one of the real sponsors of this conference down there, which I put on a slide and showed this morning. Okay? Highly robust software. Let's just pretend that we have 300-word statement, 3,000 words, but these are 3 of the words. Okay? Now, I'm going to ask you to count the number of words that violate either Rule 1, unambiguous, or Rule 2, clear enough to test. And your count is...
So we have highly robust software. Highly is obviously ambiguous.
Ambiguous, and how do you test it? Right.
Yes.
Okay. So actually, there are two faults there. It is both ambiguous
And
and
untestable.
untestable. Okay. We now count two major defects in the communication.
Sure.
Next one, robust.
Yeah, the same.
Same. Two more. Software.
Same, probably.
Exactly, because
Yeah.
you're not, for example, you're
What
not
is
saying whether you're
software,
including data and databases, and some people think you're only including code, and this is not clear. Okay, so now we have, in three
And
words,
a
we
lot of
have
people think about
6
software,
faults
they
in
also think
communication.
about hardware,
Yeah,
too.
yeah. Well, we have 6 faults in communication. Okay, now I would say that is as bad as communication can possibly be. Okay,
But
now
can
I
you
believe
get a communication that is fully ambiguous and
unambiguous.
testable?
Exactly. So if I take the trouble to define robust as some scale of measure, for example, let's just say we talk about percentage availability and say that's what we meant by robustness. That's a clear idea. And software, we say absolutely everything that is not hard and does not have a weight, and specifically including instructions, procedures, training courses, data in databases, and logic and configuration management software, and everything like that. That's all software. If you can't weigh it, it isn't software. You say that's software. And highly is moving from the robustness of it breaks down every 30% of the time. Sorry, it's available 30% of the time till we want to go to 99.98. Now I have made it unambiguous, clear, and testable.
Yep, I agree. That makes sense.
Yeah.
So now you can use the value system to create real communication.
Yes. And you can measure how bad the communication is by simply asking people to count rule violations according to some standard of good communication, of which I only gave you 2 examples. In the book Competitive Engineering, there are about 100 other rules like that, such as all quantities should be quantified with a defined scale of measure. You see? And another one is when estimating, another quality is when estimating how good a strategy is, you must give the evidence for the estimate. These are standards. If you violate those standards, if you have an estimate how good it is and no evidence.
How long does all this take to provide this language? This
okay, I'll tell you how long.
Language.
We have a startup procedure which is on our website. It's for starting the evolutionary process. We've used it for 30 years. It works like this. It's a 1-week process, no matter how big or small the project.
How many people are involved?
Usually a handful, a roomful. Okay, so it can be.
How big is a room?
It is from 5 to 15 people in practice.
Okay.
In real cases. Okay. But the process is very well defined, but it works like this. On Monday, we attempt to identify the top 10 critical attributes according to the powers that be. They tell us what they think is critical.
All the stakeholders gather together.
Well,
they do
not
an open
all,
space
but
or something.
Well, no. First, if you have 40 different stakeholders, you cannot gather all the stakeholders in a room. So you get dominant stakeholders like the people paying for it on their budget and the directors responsible and the minister. So you get a selection of powerful stakeholders who have to decide what the critical things are. We can later validate whether they've got all the critical things and the other non-present stakeholders agree. That's another process. But in our process, we start to say, whoever's here are the right people. It's almost like yeah. There's all we got. But you happen to be the directors responsible for this project. Okay, and so I'd like to say, what is the most important thing with this whole project that you think you're going to get for your 100 million kroner? And somebody will say a word like more robust systems. The old ones are falling down all the time. Fine, we write up robust.
But you don't take the trouble to translate it yet.
Not in the first hour.
Okay.
In the first hour, I'm very happy to get the top 10 brainstormed by name. Then I say, now I then ask everybody to write down the exact measurable, testable meaning of the robustness, and all of them write down totally different things. This is called the ambiguity test.
Yes.
And they all realize we have to work together to get one definition. We cannot run this thing together. We cannot.
And then you take a break, and they come with the definition.
What I do first is I work with them to show them how to get a definition, like I did here. I say, well, let's talk about a little bit. Okay, so that would be a scale of measure like this. I do it for them.
Is that part of a ubiquitous language, basically? No?
This is language. I demo it in language, in practice, as I roughly did here. Okay, I wrote down there. And then I say, do you guys like this? Now, it turns out, after about an hour of, well, I don't like that, you've forgotten that, we end up modifying the scale so it's a really good definition of what they mean by robustness. And everybody quiets down, nobody has any objections, nobody has any ideas, you're not perfect, but you're damn good. And then we say, right, on that scale of measure, how good is the previous system? And there are people in that room who know something about it. Like, well, it's sure as hell not better than 10%, no matter what. I can prove that. I'm the fire chief, And say, anybody else have an opinion? Well, from the police point of view, it's not better than 5%. All right, so it's down there. It's a reference point. We can do research on it. We can get good numbers. Maybe they already exist. Maybe they don't. Doesn't matter. But we say, okay, something like 5 or 10%. Now, how good does this system have to be for the honor of Norway and terrorist attack? And let's just say the government minister for police and justice is there, and the defense minister, and they say it's got to be at least 99% and hopefully a hell of a lot higher. So you write down goal. When does it have to be? Well, I mean, like last year, but we certainly can't wait more than a year or two because terrorist attacks could happen at any time. So what about, what about going symbolically for 99% within 2 years, if we can do it? And they say, well, that'd be nice, because we've already spent 8 years and got nothing. Okay? And by the way, if we get to 99% earlier, like in a month, we can raise it to 99.9. But why raise it to 99.9 before you're at 99? Okay? So we can have a series of
But
points.
how do you know you can get to 99 in 2 years?
You don't.
So it's just a goal.
It's a goal in the sense of that's what we want. It's a stakeholder value.
Oh, it's a vision, really.
You can call it a vision if you like. However, now, if somebody might say, well, wait a minute. 21 other countries we surveyed building emergency systems. None of them have got to the 99% thing without at least 10 years of effort, and that was Israel. Okay, and so it's not an impossible goal to go to 99%, but the evidence is the average country uses 7 years to get to 99%. They get to 70% within 2 years. They say, okay, you want to be realistic? And they say, no, we're Norway, we're rich, we can fund anything. Okay, and this is top priority or we won't get reelected, says the Prime Minister. So we're going to go for 99% in 2 years and put all the money and people in the universe into it to save our political position. It might not work, but we're certainly not, money is not going to stand in the way, nor is any human being we can hire in the whole world. We'll hire the whole of India to do the project if necessary. And they mean it and they got the cash to back it up.
Yes.
Now, a country like Greece would say,
let's just eat some souvlaki and go.
Minus 10 euros for the whole project. You can destroy Greece if you want to.
Sure.
So there's no question of going for 99% in any time frame, unless the Germans fund the whole project.
Okay.
Yeah.
So
there's negotiation, but then finally there is, okay, we set 99%, we have unlimited budget, and we talked to some technical people, said, you know what, we did the system in Israel. And we have a cheat here. We're going to simply copy the damn system in Israel as already is at 99%. You will pay us a small fortune, and we'll get to 99% within 1 month by just installing the Israeli system and translating it to Norwegian.
But when does all this learning occur? During that 1 week? Or is it just that people already know that?
Okay, no. Some people know things already. They have learned.
Yeah.
Some people will learn shortly because they have to figure it out this week or month before they commit. And some people only learn gradually and years later. So there are all kinds of learning at all times about all kinds of things. Mm-hmm. Okay. But the point is, with numbers, there is a device for learning. Okay, you learn, can we get to 30% with the yellow stickies? No.
So what I sense is that it's not that numbers are a device, but without numbers, you've already lost.
That's right.
Yeah.
We know from all kinds of international surveys that 50% of all IT projects roughly are total failures. Mm-hmm. Another 40% are partial failures. And sometimes one British survey was less than 3% were considered successes. Okay?
Yeah, but we don't have a good definition for success.
Well, there are definitions.
There are multiple.
There are multiple, but I have to admit, one of the surveys I saw shocked me when I years later read that success was if you didn't run more than twice over budget. And I'm like, what? That's success?
Now that's an industry I want to work in.
Yeah, right. Okay. No, there are definitions. For example, I'll give you a simple definition. It says, if you have set 10 numeric measurable things like this and a date for them, if you reach all 10 within the dates, you can safely say it's totally successful according to the criteria we set out at the beginning of the project.
They have to be fully under your control.
That is an engineering definition of done. And we wrote a paper in Agile Record about that, which you can have a copy of anytime you like. Definition of done is reaching the numeric goals on time. That is a clear, what is not to understand about done? We want to get to this level by 2013. It's 2014, you're at that level, you're not done. It's logically extremely clear what is done and not done if you use numbers for...
What happens when reality changes in the middle?
which we assume. So the whole of language is built on lots of risk and uncertain systems and chaos and everything like that. And but let's take an example. Give me an example of a change in the middle, just anything arbitrarily. And I will walk.
Well, okay, you need a security system, but we realize that terrorists have found new ways to insert bombs, and it's inside their underwear.
Right.
Okay, so the whole system needs to now recognize underwear bombs.
That's right. Okay, so first thing we do is to say, is this so critical that we need to integrate in our system now, or can we wait until we've done the first project? And there will be a decision. We can wait or we can not wait.
And then it's like a steering committee or something like that?
Yeah, let's assume there's a steering committee or something like that. And there always is. Somebody has to take responsibility for all that money. Okay, so this is saying, no, it has to be now, as soon as possible, because the bomb already went off with the one underwear. And
it's literally a guy with smoking underwear.
Smoking underwear.
On his way.
Right, okay. So the first thing you do is you acknowledge it has to go in instantly, okay, in some sense. So you put it in your requirements, okay? Probability of detection of smoking underwear, 99.9%. Within 10 seconds of entering the airport. Okay,
sure.
Right, now, next question is, we have, let's say, 100 other very high priority things already in there and already scheduled. Does this have a higher priority than anything else? Now, let's just say for the sake of argument, says yes, it has a higher priority than any of those others.
Yeah.
I say, great, that's what we're going to do next week. We're going to work on the smoking underwear problem. That is our priority.
Why next week?
Next week is the cycle of delivery. So at every cycle, you can make a decision to insert any new thing or reprioritize anything and do it
Why
next week.
Why not in the middle of the week?
It's in extreme emergencies, like we will all die if we don't do this in an hour, then I would do it right in the middle of the bloody week. But
yes.
Normally things where we've tolerated projects being 8 years late and doing nothing, then normally 2 or 3 days plus or minus doesn't make a damn bit of difference.
Okay.
It doesn't go into the project. It's somebody run out there and take everybody's underwear off at the airport, damn it. Forget the IT system.
So we have a guy with smoking underwear, and we need to start this now, and the guy says, talk to me in 3 days.
Sorry, which guy says to whom? Talk to me about what in 3 days?
Well, we're in the middle of a week right now.
The middle of a week, yeah. Actually, we have a delivery team.
Talk to
we have
me in 4 days.
No. Okay. We have a delivery team,
yeah.
And they're committed to this week. Okay. Now, what we might do is says, do we abort this delivery team because we've got something 100 times more important, and focus them on that? And somebody says no. Well, is there anything we can do? Is say, yes, we have a parallel team that will start working on this instantly, and I'll go out to the airport and strip everybody's underwear off and test it with a litmus test. And that's what we're going to do today.
Yeah.
We don't have to build a system.
So again, copying the Israeli system.
Yes.
Okay.
Of not letting me out with the Mac of the
There
control.
you go. You see, so it's a full circle.
Yes.
Okay, so do you have any closing words?
I will summarize.
Okay.
Quantify your critical few objectives and use them to manage your project. And quantify by estimation the goodness of any and all strategies so that you pick strategies of high value, low cost, and thus high priority, and do them first. And deliver working systems which you measurably can say that value has been delivered. We've gone from 30% to 60% this week. There's no doubt about it.
Okay.
That's it. That's the whole method in a nutshell.
Pretty simple.
Yes, very simple.
Very quantifiable.
Very quantifiable.
Tom Gilb,